relative to the origin on a long straight beach, the position vector of a speedboat is modelled by the vector r. Okay, so in vectors, this is position, basically, displacement. The position is 2t plus 2 in the I direction, and 12 minus t squared in the j direction. I and j unit vectors horizontal and vertical to the beach. Distances are in meters, and time t is in seconds. Okay. Part 1. Calculate the distance of the boat from the origin when the boat is 6 meters from the beach. Calculate the distance. Have I copied that down properly? Calculate the distance of the boat from the origin when the boat is 6 meters from the beach. Yes, I have copied that down correctly. Any ideas? Well, I think what we need to do first of all is to get a little diagram of what's going on. We have a y-axis and an x-axis, and there's our origin. Okay, so our position vectors are done from this origin. Ij unit vectors horizontal and vertical to the beach. Okay, so J is vertical to the beach, so my beach has to be here. This is my beach. Y-axis is my beach. Okay. And the expression R is equal to 2t plus 2 I plus 12 minus t squared j. Okay. Now, 6 meters from the beach, the particle is going to be here, and this distance is going to be 6 meters. Okay. So how could we work out? We need to work out the distance of the boat from the origin. We need to work out this distance. Okay. So, little problem. Any ideas? If we're using this equation here, Sean.
Would you work out t by subbing in 2t plus 2 is equal to 6?
Brilliant. Yeah. Now, the idea, basically, this coordinate, the coordinates of this, we know the x coordinate is 6 because it's 6 meters from the beach, and we know the y coordinate is 12 minus t squared, whatever t is. We don't know what t is. That's the whole point. But we can find t by saying, well, our I direction, that's our x direction, so this has to be equal to 6. 2t plus 2 is equal to 6, gives me a t is equal to 2 seconds. Okay? Then, subbing t is 2 seconds into the y coordinate will give us our y coordinate. Okay? So 12 minus 2 squared is 8. So this coordinate, it isn't 12 minus t squared now because we worked it out, it's 8. Does that make sense? What I've done there? Yeah? Bit fiddly. The diagram really helped there. What about the distance then? How could we calculate that distance? Now we've got the coordinates 6 and 8 from the origin. Sam? Pythagoras. That distance there is 8 meters. So the distance is going to be the square root of 6 squared plus 8 squared. going to be what? 10. It's a 3, 4, 5 triangle basically. But 6, 8, 10 triangle. That it's a multiple of the 3, 4, 5 Pythagorean triple. So 10 meters from the beach. Okay. Nice and cushy, nice and cushy. What about the second one? Find expressions for the velocity and acceleration at time t. And this is really where we looked at where we were at yesterday. R is equal to 2t plus 2I plus 12 minus t squared j. We need expressions for the velocity. Now velocity is going to be a vector now, and the acceleration. What's your gut instinct for velocity? How do we work out the velocity if we know the distance? Patrick? Differentiate. Yeah? For those of you who weren't here yesterday, to get from the distance to the velocity, we just differentiate. To get from velocity to acceleration, we also differentiate. Okay? So we've got vectors, but we differentiate each one separately. 2t plus 1, how does that differentiate, Jake?
No,
2. 2i. 12 minus t squared, how does that differentiate, Simon?
minus 2t.
Yeah, so minus 2t j. Right, acceleration, we've got to differentiate them again. What happens if we differentiate 2, Scott?
We get 0.
0, nothing. So there's no acceleration in the I direction. This I direction here, the particle is never going to be accelerating in that direction. It's always going to be accelerating upwards. And 2t minus 2t, how does that differentiate 2, Liam?
Minus 2j.
Minus 2j. So we have a constant acceleration of minus 2 in the j direction. So the particle is always accelerating downwards. Okay. Now, that's fine. That's just a bit of bog standard differentiation. I love this question. Is the boat ever at rest? And explain your answer. Can anybody tell me, explain why, using these 3 expressions, whether the boat is ever at rest? What does at rest mean? At rest means what? Not move. Yeah, it doesn't move. No. Velocity 0. So can somebody explain why, if we look at the velocity as a vector, 2i minus 2t j, can you explain why that would never be 0? Jake. Yeah, Jake.
Because there's always like.
Brilliant. At t is 0, the velocity in the j direction is 0, because 2 lots of 0 is 0. But there is always going to be, with the I direction, no matter what the time is, there is always going to be a component in the I direction of the velocity. Okay? So, as I component is never 0, the velocity is never 0, and it can never be at rest. So the boat is constantly moving. Not moving forever, because that would require an infinite amount of fuel. And unfortunately, we live in a world where that is not the case. But anyway, I don't know what I'm talking about there, to be honest. We proved that it's never at rest because the velocity, this component, can never be 0. Okay? Now, part 4. For t is 3, calculate the speed of the boat and the angular direction of its motion. Right. T is 3, that means I'm probably going to have to do some substitution. Calculate the speed. Right, I'm thinking the velocity expression. The velocity is 2I minus 2tj, and at t is equal to 3, what is the velocity going to equal? Go on. 2I minus 6j, because 2 times 3 is 6. Okay? Now, this is a vector. And if we remember, our j direction is that way, and our I direction is that way. So this vector is going to be going 2 across and 6 down. Oh. 2 across and 6 down. This is our vector. This is the direction of motion. At t equals 3, the particle is moving in that direction. Okay? So we need to calculate that direction, so the angle. And we also need to calculate the speed. Now the speed is going to be basically the magnitude of this vector. So how do we work out the magnitude of this vector? How are we going to work out the size of that vector? Come on, Liam. Pythagoras. The square root of 2 squared plus 6 squared gives us root 40, or 2 root 10. A bit of a moment there. Yeah, all right. A bit of a moment. How do we calculate that angle? Inverse tan of the opposite, which is 6, divided by 2. So, using the calculator, does Sam muttering? You're being recorded. So I can show that to your parents. Can't I?
You should have thought it was 12:36 week upon there, your son's muttering.
Well, it's a general, proof that you're muttering and not listening.
Or proof that I muttered once.
Yeah, proof that you're muttering and distracting the teacher from doing their job.
Proof that it's easily distracted.
Proof that for a teacher to explain some complex advanced level mathematics, to have someone muttering in the background is very distracting for them. Can make easy mistakes. Can make calculations like this take a couple of minutes. You will never win. You will never win. Okay? Yeah, so essentially, motion in 2D. It's not a problem, but everything is involving vectors, okay? And we can differentiate the I component and j component separately. If they're asking for speed, they want to, you'll have to use Pythagoras on that velocity vector. Okay? So speed is different to velocity. Velocity is the vector, speed is the magnitude of that vector there. Okay? Stop tipping. Proof. I'll ask you once not to tip. Any questions with this?